Okay, so now that we're used to what a summation is, right? Before we get into the actual proof by mathematical induction, what we're going to do is we're going to extract some formulas, right? We're going to learn how to extract a formula of a summation. So we've discussed what summations are. But then over here, question 9 states, generate the formula for the sum of the first n positive integers. In this case, what I mean is, say we have our sum s being equal to 1 plus 2 plus 3 plus 4 plus dot 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 plus n. We don't know how many integers we have, so we just say plus dot dot n, right? Now, in fact, before I get to this point, let's just divert a bit and I explain it in an easier manner. So say for instance it was to find the sum of the first three integers. What would we do? We say s is equal to 1 plus 2 plus 3, right? Then now, how we do it, so this is just the first three integers, so I won't do it normally where we just say, okay, this is 6. So what we do is that we say s plus s is equal to 1 plus 2 plus 3. Then we'd come over here down and say, now in reverse order, we'd say 3 plus 2 plus 1. Reason we're doing this is so that we can now pair these in groups of 2, like so, right? Which will then give us 4 plus 4 plus 4. Now, in doing this, we can simply say, okay, 2s is equal to 3 by 4, like that, right? Which means 2s is equal to 12. Now, if 2s is equal to 12, we can simply divide this by 2 and say s is equal to 6, which we actually have here. So, we're going to use a similar process, only the fact that we don't know where this is ending. We don't know where our summation is ending. Instead of the first 3 integers, we're going to have the first n integers. So, how we're going to do this is as follows. We're going to say 1 plus 2 plus 3 plus dot 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 plus n, right? Then now we're going to say, okay, s plus s, or 2s, is equal to 1 plus 2 plus 3 plus dot 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 plus n plus, what's the previous term to this one? It's n minus 1 plus n minus 2 plus dot 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 plus 1, right? Which is then equal to, if we add these two together, we're going to have n plus 1, right? That's our first term of these two together. Then it's going to be n minus 1 plus 2, which is just n plus 1. Same thing for this one. This will just continue repeating. I don't even need to mention what these things do. These will just continue repeating the same thing. So it's going to be n plus 1 plus dot 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 all the way n plus 1, like that, right? So this continues throughout. Now, we multiply by n. The reason I'm multiplying by n is as follows. Over here, these were n terms, right? The number of terms here were n. The number of terms for this one were 2n. Now, since we've grouped them in pairs of 2, it's more like we kill off these 2 because we're dividing the number of terms by 2, isn't it? In that case, over here we're going to have n terms. So, 2s is equal to n, right? Is equal to n, open brackets, n plus 1 over 2, right? This is what we have over here, right? This is what, sorry, not the over 2, kind of moving faster there. So now, s is going to then equal, so we're going to divide both sides by 2, and then we're going to have n plus 1 over 2. So, this is the formula for that over there. This is the formula for the sum of the first n integers. And then, moving from here, we can just divert our solution over here. We can then come and say, the summation up to n starting at I is equal to 1 for the function being I is equal to n plus 1 over 2. Now, how this formula works is, say we've been told to find the sum of the first 5 integers, right? So, for example, we've been told to find the sum of the first 5 integers. Instead of me saying 1 plus 2 plus 3 plus 4 plus 5, right? Which would give me, that would be 5 plus 5, which would give me, I think, 15 over here, right? Instead of me having to do all of this, I can simply go into my formula right? Simply go into my formula. I can plug in a 5 where I have n, so I can say 5 plus 1 divided by 2, which is 5 by 6 divided by 2, which will then give me 15, right? So instead of me having to add those things, I just have a simple formula. So no matter, even if someone's telling me, okay, find the sum of the first 100 integers, instead of me having to say 1 plus 2 plus 3 plus 4 plus etc etc, just say 100 by 100 plus 1 divided by 2. We're done with that, right? So this is how we find the summation for this. And for the remaining two, I'll leave that as exercise for you guys to handle. So just to give you a heads up, the formula for these guys will go as follows. So this is for A. So for B, the answer you should end up with should be something like n, the summation of I is equal to 1 of 2I is equal to n, open brackets, n plus 1. Then for C, the solution should be n summation I is equal to 1. Then over here, so the standard form of an odd number is, in this case, the way I solved it was 2I minus 1, right? 2I minus 1 is equal to n squared, right? So you can do this however you wish. Yeah, you can do this in whichever way you wish to solve it, but this is it for this part of the this part of the question. So next video we're going to now use mathematical induction to solve one of these.